वेलकम बैक। हम कर रहे थे इन टेक्स्ट और एग्जाम्पल ऑफ एनसीईआरटी हेलोअल्केन हेलोअरीन चैप्टर। तो 10.6 in text question is arrange each set of the compounds in order of increasing boiling points. So see, the boiling point, boiling point is proportional to intermolecular attractions, and these intermolecular attractions are proportional to size. And size means number of carbon atoms. More is the number of carbon atoms, larger is the size of the haloalkane. And it is also inversely proportional to branching. If number of carbon atoms are same and there is a branching, then surface area decreases. Actually, boiling point is, or intermolecular attractions, proportional to surface area, means surface of contact. So as branching increases, surface area decreases. Now, and it is also proportional to molar mass. That means if number of carbon atoms increases, or if number of halogen atoms increases, in both cases boiling point increases. So let us start with first one. It is bromomethane. So bromomethane is CH3Br. Bromoform, it is CHBr3. Then chloromethane, CH3Cl, and dibromomethane, it is CH2Br2. So now, which one has highest boiling point? Say number of carbon atoms are equal. So now we go to next part, that is number of halogen atoms. So number of halogen atoms, in the first case there is 1 bromine, there is 1 chlorine, 3 bromine and 2 bromine. So which one has highest boiling point? Obviously the one with 3 bromines. Then it is with 2 bromines. Now 1 bromine and 1 chlorine. So which one has higher boiling point? The one with higher molar mass, because it is also proportional to number of electrons. So CH3Br, and then it is CH3Cl. So this is the order of the boiling point. Second one, first is 1 chloropropane. Second one is isopropyl chloride. It is also called 2 chloropropane. And last one is 1 chlorobutane. So tell me, which one has highest boiling point? The one with more number of carbon atoms. Obviously it has higher molar mass as well. So because all of them have 1 chlorine only. So we compare with number of carbon atoms. So third has highest boiling point because it has large surface area. Then what about second and third? Both have same number of carbons, both have same number of chlorine. So it is first one which has higher boiling point. Very good. And then it is second. Why? Because in first case all are in straight line, but in this case there is a chlorine is in the branching. It's at position 2. So third, first and second. So as branching increases, surface area decreases. So this is the order of boiling points. Next question. This is in text question 10.7. Which alkyl halide from the following pairs would expect to react more rapidly by an SN2 mechanism? So reactivity of alkyl halide, it is inversely proportional to steric hindrance. More is the steric hindrance, lesser is the reactivity, because in SN2 there is an attack from the back side. The attack takes place from the back side, like CX. So nucleophile will attack from the back side. So if these groups are bulkier, then attack is hindered. So it is inversely proportional to steric hindrance. So tell me, order of reactivity is primary is more reactive. In this case, primary alkyl halide is more reactive than secondary than tertiary. So just see which one is more reactive. In first case, bromine is attached to primary carbon. Here, bromine is attached to secondary carbon. So it is secondary alkyl halide and this one is primary alkyl halide. So which one is more reactive? Just see the order. Primary is more reactive. So that means first one that will react more rapidly by SN2 mechanism. Now come to second pair. So in second pair, bromine is attached to secondary carbon and here bromine is attached to tertiary carbon. Bromine attached to tertiary carbon, here bromine attached to primary carbon, secondary carbon. So which one is more reactive? Obviously, which one is more reactive? First one, because it is secondary and order of reactivity is primary, secondary and tertiary, and that is inversely proportional to steric hindrance. Last one, see, bromine is attached to primary carbon, here bromine again attached to primary carbon. Now which one is more reactive? Tell me. Yes, now which one is more reactive? Both are primary. Yes, then we say the second one. See, here it is secondary and on the other side it is tertiary. So obviously hindrance is more on this alkyl bromide than this. That's why this one is more reactive. In all the three cases, first one is more reactive than the second one. Identify chiral and achiral molecules in each of the following pair of compounds. Wedge and dash representation according to class 11. So wedge, this wedge means group towards the observer. Wedge represent that group is, this wedge means group is towards the observer, and dash means group is away from the observer, and these normal line means these groups are on the plane of the paper. Okay, now this carbon is attached to 4 different atoms or groups. See, this carbon is attached to hydrogen on one side, methyl, then bromine, then OH. All the 4 atoms or groups are different. That's why this carbon is called chiral carbon. So carbon attached to 4 different atoms or groups is called chiral carbon. And if a molecule has only one chiral carbon, that is called chiral molecule. That molecule is called chiral molecules. Next one, see, in the next one, 2-bromine. This carbon is attached to 3 different groups because there are 2 same groups, that is bromine atoms. That's why this molecule is achiral. First is chiral and second one is achiral. The molecule having chiral carbon, that is called chiral molecule, and one having no chiral carbon, that is called achiral molecule. That's it. Now this carbon attached to 4 different groups, So this is chiral molecule, and here HOH CH2 CH3. So same groups, means this is a chiral and this one is chiral. Next one, this chiral carbon just represented by star. Here see, one side it is attached to methyl, on the other side it is attached to ethyl, bromine and H, means 4 different atoms or groups are attached. So this is chiral molecule, and here it is a chiral because there is no chiral carbon at all. So it is a chiral molecule. In text 10.8, and now the following pair of halogen compounds, which compound undergoes faster SN1 reaction. Now SN1 reaction. For SN1 reaction, reactivity of alkyl halide is proportional to stability of carbocation, because in SN1 slow step is the formation of carbocation. So it is proportional to stability of carbocation, and you know carbocation tertiary is more stable than secondary than primary, and so is the reactivity of alkyl halide. Tertiary alkyl halide is more reactive than secondary and then primary. This is for SN1, and for SN2 just reverse. Primary is greater than secondary, greater than tertiary. Now, so tell me, this carbon, as this carbon is attached to two other carbons. Carbon attached to chlorine is attached to other 3 carbons. So it is tertiary carbon. So it is tertiary alkyl chloride. And this one, it is attached to 2 carbons. So it is secondary. That means out of these 2, first one is more reactive because it's tertiary alkyl halide and its tertiary carbocation is more stable. Now second one, this carbon is secondary, so it is secondary alkyl halide, and this one is primary, so obviously secondary is more reactive. Very simple. Any doubt up to this? Kshitij, have you any doubt? Okay. Next, although chlorine is an electron withdrawing group, yet it is ortho-para directing in electrophilic aromatic substitution reactions. Why? So beta, first of all, chlorine when attached to benzene ring, it has 2 types of effects. Chlorine being more electronegative, than carbon, it has minus I effect, because inductive effect just say the electronegativity. The one group which is attached to carbon or atom attached to carbon, what is its electronegativity? That will decide its inductive effect. If it is more electronegative than carbon, then it has minus I effect. Otherwise, if it is an alkyl group is attached, then that has plus I effect. Okay, so chlorine being more electronegative than carbon, it has minus I effect, and at the same time chlorine has lone pair, which is in conjugation with pi bonds of the benzene ring. Conjugation means lone pair and double bond, they are separated by a single bond. That is called conjugation. So that's why it has plus R effect. Chlorine being more electronegative, yes, you are right. First, I am telling you what are the effects of chlorine on the benzene ring. Okay, first effect is that chlorine, because it is more electronegative than carbon, so it has minus I effect. And second is due to the presence of lone pair on chlorine, which is in conjugation with the ring, that's why it has plus I effect. Two effects are there. Okay, now so when it undergo resonance, due to resonance, electron density increases at ortho and para position. So electron density it increases at ortho and para position. See, in the this is first, second, third, and fourth. Out of these, second, third, and fourth has negative charge and ortho and at ortho and para position. Now, see, when it has this negative charge, so electron density at ortho and para position is more, but at the same time, chlorine being more electronegative than carbon, it withdraw electrons from the benzene ring, and that's why it decreases the electron density on the benzene ring. It decreases the electron density on the benzene ring. It means chlorine. Chlorine decreases the electron density on the benzene ring due to minus I effect. Due to minus I effect, and that's why it is less. It has less electron density than the benzene itself. But at ortho and para position, it is counteracting due to plus R. Electron density increases at ortho and para position. That's why it is counteracting, means the decrease in electron density is less at ortho and para position. That's why it is ortho para directing in electrophilic aromatic substitution reactions. So keep in mind, that's why minus I effect determines its reactivity and plus R effect determines its orientation. Okay, minus I effect जो है determines the reactivity and plus R effect determines the orientation for chlorine. That's why because of minus I effect it is electron withdrawing, and due to plus R effect it is ortho para directing. 10.9 9 in-text question. Identify A, B, C, D, E, R and R1 in the following. So first case, we have bromocyclohexane. When it comes in contact with magnesium in dry ether, we get Grignard reagent, means magnesium entered between carbon and bromine. So we get organometallic compound, means carbon metal bond is there. This is Grignard reagent. Now in the presence of H2O, Grignard reagent is stable under anhydrous condition. Even a trace of moisture, it can react, and therefore, here it is negative and it is magnesium is positive and carbon is negative. H2O give H plus and OH negative. So we get cyclohexane along with MgBrOH. So that means this one is a cyclohexyl magnesium bromide. Cyclohexyl magnesium bromide, and this one is cyclohexane. Now second one, RBr react with magnesium in dry ether. So we get RMgBr, and RMgBr when react with D2O, it give D plus and OD negative. So it gives RD and MgBrOD. And this R is this one, CH3 CH3. That means this RD is CH3 CH3. So C is CH3 CH3 MgBr. So this one is C. Isopropyl magnesium bromide. Isopropyl magnesium bromide. Third one, R1X react with magnesium, so it gives R1 MgX. Then with H2O, it gives R1H along with MgXOH. What is R1? That we will see. So with sodium ether, yes, tell me, alkyl halide with sodium in ether, what is the name of the reaction? Alkyl halide, R1X means alkyl halide with sodium in ether. What is the name of the reaction? This one. Yes, tell me, what is the name of this reaction? Alkyl halide with sodium in dry ether. The name of the reaction is Woods reaction. And in this reaction, we will get this product. So that means what is R dash X? R dash is tertiary butyl group, and R dash X. So that means when this react CH3 C CH3 CH3X when react with sodium in dry ether, so we get this product. And second reaction is CH3 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 CX with magnesium in dry ether, so we get CH3 CH3 MgX, and with H2O it will give CH3H along with MgXOH. So see this one, this is A. So A is cyclohexyl magnesium bromide, B is cyclohexane, then C is isopropyl magnesium bromide, and D, okay, D with Mg R dash. So this is D, and D is tertiary butyl magnesium halide. And what is the name of this compound? 2-methyl propane or isobutane. So this is E. Yes, this is E. And what is R dash? That is tertiary butyl group. तो हेलो फ्रेंड्स, मैं आपके लिए लेके आ रहा हूं NCERT ऑफ क्लास 12th रोज शाम को 6 से 7, जिसमें हम पहले बेसिक कंसेप्ट्स करेंगे NCERT बेस पे, उससे रिलेटेड MCQs करेंगे, फिर हम उसी से रिलेटेड नीट जो उसके एडवांस लेवल के कंसेप्ट है वो करेंगे, नीट की प्रैक्टिस करेंगे, प्रीवियस ईयर जेई मेन के प्रीवियस ईयर क्वेश्चंस की प्रैक्टिस करेंगे, और ऐसे हम हर चैप्टर के लिए करेंगे। और लास्ट जो हर चैप्टर का लेक्चर होगा दैट इज वन शॉट, कि 1 घंटे में कैसे आपको पूरा चैप्टर रिवाइज करना है वो भी हम करेंगे। तो आपके लिए एक गोल्डन अपॉर्चुनिटी है जिसको आपको ग्रैब करना है, ठीक है। तो उसके लिए आपको क्या करना है, ये जो सब पैकेज है इट इज टोटली फ्री, और सारे लाइव सेशंस है। देखो ये 1-to-1 आप इंटरेक्शन कर सकते हो, मेरे साथ चैट कर सकते हो, और ये सब कुछ फ्री मिल रहा है ओनली ऑन इंडियाज फर्स्ट सोशल ई लर्निंग प्लेटफॉर्म द नून ऐप। So download the Noon app, sign up and join my group, and see you there from 6 to 7 every day only on Noon app.